What are the various sources of biomass for biochar? We call feedstock usually, that's a common term. Biomass from crop residue, weeds, surplus biomass, grasses, excess forest litter which is permissible to be taken away by communities, animal manures, municipal waste, that is organic waste, etc., can be used for conversion into biochar. Therefore, the process is a means for managing waste. There is nothing called waste otherwise, because in the cycle of waste management, every waste has a value except the synthetic or chemicals and few other substances. Mostly the bio waste is having lots of value for the environment and the soils. Efficient biochar production prevents wasteful burning of millions of tons of post-harvest biomass in open fields and the resultant emissions. We have issues like stubble burning, especially in many rural areas. This is because the fodder is used for animals as feed is not being used much because of mechanization, and the farmers are unable to manage this biomass as a commercial material, and there are few takers, and they need to prepare themselves for the next crop. So that way they have lots of challenges. So a majority of small and marginal farmers can easily adopt efficient biochar production technologies using the biomass available in their fields and surroundings. Sludge from sewage could also be safely converted into biochar. These are the various other options we have, provided that it is tested for harmful elements. The domestic sludge in some areas is permissible, not from the industrial waste that has lots of heavy metals and many contaminants. The resultant biochar can be used to reduce emissions from sewerage and water treatment systems. Here, for the environmental services, different applications we need to work on. Say, the biochar produced from the sludge, which has some undesirable pollutants, this can be used for filling the mining sites as part of carbon sequestration, or sometimes to cultivate energy plantations and other things where they are not consumed directly. One has to be innovative. Say, we could use for the construction materials inside, which doesn't radiate or emit directly. Lal, a scientist, he estimates that the world production of crop residues to be 4 into 109 mg per year. That's very huge. Taking the mean carbon content to be 48% and a pyrolysis yield of 48% of this carbon in the char, a maximum of 1 pgc per year biochar could be produced from agricultural residues if all current global agricultural residues were converted into biochar. In practice, this figure will be constrained by cost, suitability of different residues, requirements to incorporate residues into the soil, and other competing demands. How much biochar might be produced from agricultural residues once such constraints have been taken into account is a question that requires further research. Prosopis juliflora, this is a weed in India because this particular species came from Mexico and it is spread across India. So this waste material is available in plenty and it doesn't get in clash with the forest species as it is exotic. So it can be used in biochar production. So here when people are producing biochar using this Prosopis juliflora, the location where they have produced, we have materials left such as a combination of fine charcoal mixed with burnt earth, which can be sourced from local charcoal kilns. Rice husk biochar can be found in local parboiled rice mills, which is a byproduct of using rice husk as a fuel for the boilers. Similarly, we get the residue biochar from gasifiers also. Exotic and invasive species of plants, residue from crops that are otherwise burnt in the open. Energy plantation, they are specially cultivated, including the waste from the plantations such as eucalyptus, subabul, which are cultivated for the sake of paper industries. Apart from supplying the main logs of wood, there is always some material left, and the timber waste and other numerous sources of biomass are available for biochar conversion. Prosopis juliflora is an exotic species in India and grows profusely in all conditions, especially in the degraded fallow lands which are left due to salinity, alkalinity. It is a major source of biomass available from fallow lands currently. Prosopis juliflora grows luxuriantly in the alkaline soils too. The biochar generated from the plant material has both commercial value as a alternative to coking coal in the form of charcoal and is used in biochar compost also. As a source of charcoal for energy, that is for burning, it has huge value and demand, and the price is also very good for the producers. So utilizing such resources minimizes impact on the environment and deforestation. Such sources of biomass exist in every region and they should be identified and used. Biomass sourced from the agriculture sector in India is about 800 million tons. Of the total biomass, at least 20 to 30% is wasted that can be utilized for biochar. Burning crop residue in the fields is a common phenomenon as a preparatory measure before sowing a new crop, especially the cotton stalks, including the pigeon pea stalks or the sugarcane industry bagasse or leaf litter, including wheat and paddy straw. Most of this biomass is being burnt currently. The percentage of crop residue burnt varies from place to place and from crop to crop. Here are the 6 major crops cultivated in India and the quantity of crop residue they leave behind in million tons are: rice 13.1, wheat 15.4, sugar 21.6, groundnut 3.3, mustard 4.5 and cotton 11.8, totaling about 69.9 million tons. This is alone for a few crops. And we can see the waste from cotton and the sugar industry and rice and wheat are the major sources of biomass. Crop residue is converted into compost or manure, but mostly ends up being burnt and turned into ash, because people are not interested to spend 3 to 6 months doing this. And they don't have much animals also, as the farm animals are coming down and mechanization is increasing. Again, when they burn openly, only some part is converted into charcoal and rest, because of excess oxygen, gets converted into ash. Ash is a valuable resource, especially in acidic soils, for its phosphorus and other mineral content. But ash in quantity, it is always less as compared to biochar. Second thing is, once an ash is applied to soil, it is a consumable thing for the soil. So it doesn't stay like the carbon in biochar, and that carbon sequestration value doesn't bring. But otherwise in acidic soils, adding ash has some value. Considering the value of biochar, especially in poor degraded soil, there is a need for technologies to efficiently convert biomass into biochar. In this regard, traditionally artisans globally across and even within parts of India where I have seen, they have innovated and designed and improved the efficiencies of the traditional technologies, which are right from earth mound kilns to the constructed with the bricks, the dome like plinths and retorts, and the pit method of doing biochar. So various methods they had been following. Apart from that, there are so many efforts, including myself. I have designed about 6 simple technologies for the communities to adopt and produce biochar locally. These are low cost efficient things that I have created. Apart from that, my own cook stoves, most of them which are efficient and also they yield very good amount of biochar, they are there. Apart from that, we have big technologies coming in the context of climate change, carbon credits and all that, including the continuous biochar production technologies or batch wise production technologies, and even the small scale technologies, the retorts are also existing as of now, including the mobile farm based technologies have also come into existence. So all these are adding lots of availability and flexibility for the local communities to adopt. And the crop residues like those of cotton plants are hard and could yield good biochar. But handling it and converting it into biochar consumes a lot of labor and energy. This is because of uh, nature of this biomass, which is like a thorny kind of thing. Of course, there are no thorns, but the sticks are like that. The abrasive nature when we touch or hold them, because the stems are very hard and the branches are there. That is one reason. Still, with the trench method, the biochar from the cotton stalks is happening on a large scale. Some thousands of tons of biomass is being converted now. The energy produced during the process of converting biomass into biochar should also be used for some practical applications. This is very, very important. So, in the traditional methods, the heat retained within the pyrolysis process is helping the pyrolysis. But the emissions that are happening in some open systems, say in the trench method and all that, we are not capturing the pyrolysis gases which can be recombusted. In some retorts and kilns we have seen they are capturing and diverting this again back to the combustion place. Apart from that, some are also wood vinegar and other byproducts like bio oil, and all these things are also being extracted. Many farmers simply burn crop residue in their fields, wasting the energy. However, thermal power plants based on biomass are emerging. These are including the gasifier plants. This industry generates ash as its byproduct and sometimes biochar plus ash as a byproduct. These thermal power plants compete with the biochar production plants for biomass, otherwise, in general. So, instead of this competition, we can devise the systems in such a way that the thermal power plants as a byproduct generate biochar, where they get the credits for this biochar. So that way they can optimize their or make their systems efficient and profitable. The crops being currently grown are improved or high yielding varieties or short duration crops, which have less biomass compared to traditional crops which were existing otherwise. They are very dwarf and total biomass is low. Even in the cotton plants I have seen, the dwarf varieties are coming. We are looking at yield, but ultimately the size of the plant is coming down. The overall biomass available as crop residue has been diminishing over the years. In this context, there is much need to create large-scale awareness among farmers about the importance of converting biomass into biochar wherever possible. In a typical semi-arid village in certain parts of India, biochar comes from the following sources. Say, Prosopis juliflora, that's a huge biomass that is available, and rice husk, which is already being converted into charcoal, and that charcoal can be used as biochar. And rice husk biochar from paraboiled rice mills is another product which is also less costlier. Of course, it has silica, ash, and other impurities, but this is available in large quantities, and as many Asian countries, rice is one of the important food crop. So this rice husk is available, and they are using for their boilers, and the byproduct we are getting this rice husk biochar. Biochar produced from crop residues is another source, and biochar from biomass cook stoves also. So however little it might be, and from wherever source somebody could get this biochar that has value.